Good day, everyone. Welcome to Richfield Hybrid Learning. My name is Silas Toperesu, and I'm your lecturer for Mathematics 512 module. Today, we're going to look at our syllabus topic 4, which is differentiation. As part of the learning objective of this topic, after completing this chapter, you'll be able to demonstrate an ability to find the derivative of any function or expression. You'll also be able to apply the different types of differential rules, such as the power rule, product rule, a quotient rule, chain rule, and implicit rule when you are differentiating any type of a function. In addition to that, you also be able to develop a knowledge on how to differentiate trigonometrical functions of any type and any form. Let's look at the history and definition of differentiation. Differentiation is part of the science of mathematical calculus and was first developed in the 17th century by two different mathematicians, Gottfried Leibniz, who is a German mathematician, and Sir Isaac Newton, who is an English mathematician. Differentiation is the process of finding instantaneous rate of change, which is an essential part of any field such as mathematical and physics, chemistry field, biology field, computer science field, engineering field, as well as navigation and astronomy field. Derivative helps us to know the change in relationship between two variables. We consider an independent variable x and dependent variable y, then the change in the value of the dependent variable with respect to the change in the value of independent variable can be found using a derivative formula or differentiation process. A derivative formula is helpful to find the slope of a line or to find the slope of a curve, as well as is helpful to find the change in one measurement with respect to another measurement. We have a number of differential notations that are used in any problem solving or finding the derivative of any function. We know that the differentiation is the process of, or is a rate of change of any function. For example, if you have the function y is equal to fx from a point of x, which is b, to a point of x, which is a, the derivative of this function is given by the formula, which is change in y over change in x, written in the form of triangle y over triangle x. And this is equal to fb minus fa divided by b minus a, which is also the formula that can give us a slope at a certain point of our fx, or a value of x, which is a. So when we're calculating a slope at the value of x is equal to a, we can calculate using this formula. So the different notations of differential equations, whenever you are given a function or expression in terms of fx, so the derivative of fx, it will be written in a notation of f bar x, which means the derivative of fx. Or when we have an expression that is given in the form of y is equal to an expression of x's, the derivative of that y or equation will be given by y bar, which means derivative, or the derivative will be written in the notation of dy over dx, which means differentiation of x of y in terms of x. Or it will be written in the form of d over dx of fx whenever you have got an expression a of fx. When we're differentiating any function or expression, we need to consider a number of basic differential rules that are applicable when we solve or find the derivative of such a function or expression. We have the first one that is called a constant rule. A constant rule is applied whenever we're differentiating a constant or a number that is not having an attachment with a variable. So we also have what we call a power rule, which is applied when we differentiate or find the derivative of a function that have got an exponent or that have got a power. We also have what we call a constant multiple rule, which is applied when we are differentiating any function that have got a multiplication of a constant. Then we have a sum and difference rule, which is applied when we differentiate a function or expression that have got two or more functions that are added or subtracted on each other. We also have what we call a product rule. The product rule is applied when we differentiate two or more functions that are multiplied on each other. Then we have the last one, which is quotient rule, which is applied when we differentiate two functions that are dividing on each other. One is the denominator and 1 is the numerator. So when we are differentiating such an expression that you've got a fraction, we can apply a quotient rule. Let's now look at constant rule. If a function f is a constant function where fx is equal to c, which is a constant, then the basic rule for differentiation, which is f bar x, which is this notation, mean differentiation. The differentiation of our fx, which is equal to a constant, is equal to 0, or a d dx or fx is equal to 0. So you write a derivative of our fx in different notation. Either we can choose to write in this notation, first notation, or the second notation, which is the d over dx of fx. It's one of the notation that mean differentiation. So for example, if I have got the function that is saying y is equal to minus 8, so when we want to find the derivative of our function y is equal to fx, which is dy dx, is going to be the derivative of d dx of our expression, which is minus 8. So any derivative of a constant which doesn't have any variable attached to it is equal to 0. The other example, in example 2, I've got fx. We have got fx is equal to 20. The derivative, which is f bar of x, which means differentiation of our fx, is equals to d dx of our 20, which is equal to 0 since we're differentiating a constant. Our second differential rule, which is the power rule, states that if a function f is a power function where fx is equal to x to the power n and n is a real number, then the derivative of our function fx, which is f bar x, is equals to any x to the power n minus 1, or we can write the derivative of fx as d dx of x to the power n, which is equals to n x to the power n minus 1. So the process of differentiating any function that have got the power is by taking the power, which is n, and we multiply n with x to the power n minus 1. So we multiply with the power and then we reduce the power by 1. For example, this question says, find the derivative of y is equal to x to the power 5. To differentiate this, to find the dy dx of 5x to the power 5, we need to take the power, which is 5, and then we multiply, and then we say x, we reduce the power minus 1. We are going to have our final answer is 5x to the power 4 is our derivative of the function y is equal to x to the power 5. Let's now look at our second example that says, find the derivative of fx is equal to root x. So root x is the same as x to the power half. So when we have got to root x, we can change it to x to the power half. And when we're finding the derivative of fx, which is f bar x, is going to be the derivative of d dx of x to the power half. So when we're differentiating x to the power half, we take half, which is the power, and then we multiply with the x to the power half minus 1. So we take the power and then we multiply with, then we minus 1 from the power. So we end up having half x to the power minus half. But to remove this x to the power minus half, we have to take x to the power minus half down to our denominator. Then it will change the status from negative to a positive. So we end up having 1 divided by 2x to the power half, which is reduced to 1 over 2 root x. So let's look at our example 3 that says, find the derivative of y is equal to 1 divided by cube root of x. So cube root of x, when we change the cube root of x, is the same as x to the power 1/3. So when we change to x to the power 1/3, we're going to have 1 divided by x to the power 1/3. But x to the power 1/3 is our denominator. We need to take this up. So when we take the x to the power 1/3 from the denominator up, it's going to change also the sign of our power and become negative. So we end up having x to the power negative 1/3. So when we apply our derivative now, dy dx on x to the power minus 3rd, we are taking the power, which is minus 3rd, then we multiply with it and say minus 1/3 times x to the power minus 1/3 minus 1. We reduce minus 1/3 with minus 1. So we end up minus 1/3 minus 1 is going to be minus 4 over 3. So we end up having minus 1/3 x to the power minus 4 over 3. And to remove this negative on our power, we take x to the power minus 4 over 3 down into our denominator, and we are going to have our final answer is 1 divided by 3x to the power 4 over 3 is our derivative for a function y is equal to 1 over cube root of x. Another basic differential rule is a constant multiple rule, which states that if a function fx is a differentiable function and a c is a constant, Then whenever we have got a c multiplied to a function and we want the derivative of c fx is the same as c times the derivative of fx bar, or we can rewrite it in the notation of d dx of c fx is equals to c times d dx of our fx. So for example, if we have got a function which is saying y is equals to 5x to the power 3, when we want to find this derivative, since we've got a constant which is 5 multiplying to our function x to the power 3, when we find the derivative, which is dy dx, is the same as 5 times the differentiation of x to the power 3. So we focus on our differentiation of x cubed. And after we find the result, then we multiply it with 5. So in this instance, when we differentiate x to the power 3, since is in form of a power, we use the power rule. Power rule on x cubed is simply say we have to take the power, which is 3, then we multiply by x to the power 3 minus 1, and we end up having our results as 15x squared. Our second example is also saying fx is equal to 3 divided by root x. We all know that root x is the same as x to the power half. So when we take x to the power half up to our numerator, we are going to end up having 3x to the power minus half. So when we define the derivative of 3x to the power minus half, we is the same as 3 differentiation of x to the power minus half. So we focus on differentiating x to the power minus half, and the result of the derivative, then we multiply that result with 3. So when we're differentiating x to the power minus half, we use the power rule. So we take the power, which is minus half, then we say times x to the power minus half minus 1, and then the result we multiply it with 3. Then we end up having the final result as minus 3 over 2x to the power minus 3 over 2. Let's look at our next differential rule, which is the sum and difference rule, which states that if a function f and a function g are differentiable functions, then the derivative of fx plus or minus gx is the same as the derivative of fx, which is f bar x plus or minus g bar x. Or we can write it in the notation of dx of fx plus or minus gx is the same as the derivative of fx alone plus or minus the derivative of gx alone. For example, that states that find the derivative of fx is equals to 4x to the power 5 plus 3x to the power 4 minus 8x to the power 2 plus x minus 3. So when we are differentiating, we need to differentiate these expression alone, then after that we add them or subtract where there is a subtraction. So to find the derivative, which is f bar x, we need to differentiate here on the first expression, which is 4x. We have got a constant multiplication of our function with the power. So we need to take the multiplication constant out, then we find the derivative of our expression x to the power 5. So when we find the derivative of a power x to the power 5, we need to take the power, then we multiply with the power, and then we reduce with minus 1 on the power, which is 5. 5 times x to the power 5 minus 1, then we multiply by 4. Then the next one, which is 3x to the power 4, we do the same and say 3 times. Then we take the power, which is 4, then we say times x, then we reduce the power, which is 4 minus 1. And the one, which is 8, also multiply with the constant and say minus 8. Then we take the power, which is 2, then 8 times 2 times x to the power 2 minus 1, which is the power by minus 1. And the next one, which have got only x, we also say x to the power 1 minus 1, because x is the same as x to the power 1. So minus 1, then we are going to end up having x to the power 0. Then the one which is the derivative of minus 3, which is a constant. A derivative of a constant using constant rule is always 0. So we put 0 as our result of our derivative of 3. So when we reduce 4 times 5, x to the power 5 to the power minus 1, we're going to get 20x to the power 4. Then 3 times 4x to the power 4 minus 1, we're going to get 12x to the power 3 minus 8 times 2x to the power minus 1, we're going to get minus 16x. And then x to the power 1 minus 1, it gives us x to the power 0, which is equal to 1. So this becomes our final result, which is 20x to the power 4 plus 12x to the power 3 minus 16x plus 1 is the result of the derivative of fx is equals to 4x squared plus 3x squared minus 8x squared plus x minus 3. Let's now look at another differential rule, which is the product rule, which states that if function f and function g are differentiable functions, then the derivative of fx times gx is equals to gx times the derivative of fx plus fx times the derivative of gx. Or we can write it in another notation of d dx of fx times gx is equals to the function of gx times the differentiation of function of fx plus the function of fx times the differentiation of the function gx. For example, that is saying differentiate fx is equals to 2x to the power 2 minus 1 times x cubed plus 3. So if you check on these two functions, there are two functions multiplying with each other. So we can label one of the function as fx and the other one as gx. So when we label them, then we substitute into the product rule formula or function. So when we substitute this one, we're going to get, if you label the second one as our gx, the third one is our fx. We are going to have the derivative of fx, which is f bar x, is equals to our first function, which is gx of x cubed plus 3 times the derivative of fx, our function of fx, which is 2x squared minus 1. So we find the derivative of d dx of the function of x plus function fx, which is 2x squared minus 1 times the derivative of function gx, which is x cubed plus 3. So now we have to focus on differentiating the function of fx, which is 2x squared. So when we differentiate 2x squared minus 1 is a constant. So by constant rule, we're going to get 0. So we focus on 2x squared and apply a constant multiplication as well as the power rule to differentiate 2x to the power 2. So when we differentiate 2x to the power 2, we're going to get 2 times 2 to the power times x to the power 2 minus 1, which reduces to 4x. And then we differentiate also our gx, which is x cubed plus 3. And when we're differentiating x cubed plus 3, the 3 is a constant. By application of constant rule, we're going to get 0. So we focus on differentiating x cubed. So when we're differentiating x cubed, we apply a power rule. By the power rule, we take the power, which is 3, then we write it and say 3 times x to the power 3 minus 1, which reduced to 3x squared. So now we have got a bracket of our function fx times our derivative of gx, as well as the bracket of our gx times the derivative of fx. So now we remove this bracket by multiplying by 4x and say 4x times x cubed, we're going to get 4x to the power 4, and say 4x times 3, we're going to get 12x. And then we remove also the second bracket and say plus, then you say 3x squared times 2x squared, we're going to get plus 16x to the power 4. Then you say 3x squared times minus 1, we're going to get minus 3x squared. Then this reduces to our final answer of 10x to the power 4 plus 12x minus 3x is our derivative of this fx expression. Here is our second example that says find the derivative of y is equal to x cubed times square root of x plus 1 in one bracket. So we can consider these two as two functions, as two expressions of fx and gx. And when you label them as gx and fx, then we can now substitute into our product rule, that is saying d dx, which is derivative of dy dx, is equals to the function of gx, which is root x plus x, times the derivative of fx, which is the derivative of x cubed, plus the function of fx times the derivative of gx. So if you remember that the square root of x is the same as x to the power half, so we can change this square root into the x to the power half. Then now we write x to the power half plus 1. Then when we focus on finding the derivative of x to the power 3. X to the power 3, we use the power rule, and we're going to get 3x to the power 3 minus 1. Then we also focus on the derivative of our gx, which is x to the power half plus 1. So on 1, applying the constant rule, we're going to get 0 when we're differentiating a 1. Then we focus on the derivative of x to the power half. Derivative of x to the power half by the power rule, we're going to have half times x to the power half minus 1, which reduced to half x to the power half. Then here also will reduce to 3 times x squared. So now we remove the bracket by multiplying 3x squared into the bracket. We're going to have 3x squared times x to the power half, which gives us 3x to the power 5 over 2. Then we say 3x squared times 1, which gives us 3x squared. And then we do the same multiplying here, x cubed times half x to the power minus half. It gives us half x to the power 5 over 2. Then we add this we add the like terms, which is half x to the power 5 over 2 plus 3x to the power 5 over 2, which gives us 7 over 2x to the power 5 over 2 plus 3x squared is our final result of this derivative. Our next rule of basic differentiation is the quotient rule, which states that if function f and function g are differentiable functions, then fx divided differentiation of fx divided by gx is equals to function gx times the derivative of function fx minus function fx times the derivative of function gx divided by the function gx to the power 2. So this is the formula of how to differentiate any two functions that are dividing on each other. For example, we have got the equation that is saying differentiate y is equal to 6x squared divided by x minus 2. So we can label these two functions, the one on numerator is our fx and the one in denominator is our gx. So then we substitute this into our quotient rule formula for differentiation. So now when we find our dy dx, we say dy dx is equals to our first function, which is our gx, which is 2 minus x, which is the denominator, times the derivative of our numerator, which is the d dx of 6x squared. Then we say minus our function of fx, which is the numerator, which is 6x squared. Then we say d dx of our gx, which is 2 minus x, divided by gx, function gx to the power 2, which is x minus 2 to the power 2. Then we solve now for the derivative of, if we find the derivative of 6x squared using the constant multiplication and power rule, we're going to get 6 times 2x to the power 2 minus 1, which reduced to a 12x. And then when we differentiate 2 minus x, differentiation of 2, since it's a constant rule, by a constant rule we're going to get 0. Then we focus on differentiation of minus x. Minus x, since minus x is the same as x to the power 1, so when we say minus x to the power 1 minus 1, we're going to have minus x to the power 1, the power 0, which reduced to minus 1, so we'll end up having minus 1. So when we solve now, we are saying 12x times 2, to remove this bracket, we're going to get 24x, and 12x times minus x, we're going to get minus 12x squared. Then we say minus 1 times minus 6x squared, we're going to get plus 6x squared, divided by this function g, which is 2 minus x to the power 2. Then we equate this and say 24x minus the like terms, which is 12x squared plus 6x, we're going to get 24x minus 6x squared divided by 2 minus x to the power 2 as our final result of our derivative of our function y is equal to 6x squared divided by 2 minus x. Let's look at our second example, which says differentiate y is equal to root x plus 2x divided by 7x minus 4x squared. We all know that the square root of x is the same as x to the power half, so we can change x square root of x into x to the power half. So the solution of this question, we find the dy dx, we substitute, we label our numerator as our fx and our denominator as our gx, then we substitute into the formula for our quotient rule. So our gx, our formula will say the gx, which is 7x, which is our denominator, times the d dx of our fx, which is x to the power half plus 2x. Then we say minus our fx, which is the numerator, times the derivative of our denominator, which is 7x minus x squared, divided by the gx function to the power 2. So now we focus on differentiating our fx and our gx. So when we differentiate our fx, we started by differentiating x to the power half using the power rule. So we are going to have half x to the power half minus 1, and then on the second one, which is 2x, when we differentiate 2x, we're going to get 2, and we focus on differentiating on the second one, which is our gx. So when we differentiate 7x minus x squared, differentiation of 7x is reduced to 7, and differentiation of minus x squared, we're going to have minus 2x to the power 2 minus 1, which reduces to minus 2x. And now we remove the bracket. We can solve the bracket to remove the bracket by applying multiplication. So when we apply multiplication, and say 7x times half x to the power minus half, and then 7x times a 2, then plus minus x times half x to the power half, then we are going to end up having minus 7 over 2 root x plus 3 over 2 root x to the power 3 plus 2x squared, divided by our a gx, which is 7x minus 4x squared to the power 2 as our result of this differentiation. Another method that is also used to solve the differential problems is a chain rule, which is also called the inside-outside rule, or it's called the function of a function rule. The chain rule is used to find the derivative of a composite function. So if we have got the function, two functions f and g, the composite function of composition of f and g is defined as f of gx, or is defined as fgx. The chain rule is applied in a number of steps when we are finding the derivative of n function. So the first step is to find whether the function is a composite function for us to be able to apply a chain rule. Then the second step, we identify the inner function and the outer function. Then the third, we need to differentiate the outer function and leaving the inner function. And then the step 4, we need to differentiate now the inner function. Then in step 5, we need to multiply the result of the derivative of the outer function with the result of the derivative of the inner function together. And then we simplify the chain rule on step 6 to find our final differentiation of our expression. Here is our example of solving the derivative of an expression using the chain rule. Our example question is saying, find the derivative of y is equal to 6x minus 8 to the power 7. So for this expression now, since it has got an inner function and the outer function, we need to let u is equal to the inner function, which is 6x minus 8. So now we have got the outer function, which is y is equal to u to the power 7. So the inner function is represented by u, and then the outer function is going to be y is equal to u to the power 7. So now we have got two functions, which is the inner function and the outer function, which is the one in terms of u and the one in terms of y. So we differentiate the inner function in terms of x, which means du dx. So when we're finding du dx, we differentiate the one that is equal to x, which is 6x. When we differentiate 6x, we are going to get 6, and the differentiation of a constant is going to be 0. So our du dx is going to be 6. And then we're differentiating y in terms of u. So here we use a power rule. So the power rule is simply said, we take 7, which is the power, then we say 7 times u to the power 7 minus 1, which we end up having 7 u to the power 6. So now we have got our dy du. So after differentiating, we've got our inner and outer differentiation. We need to multiply our inner results of differentiation and our outer function differentiation. So we say dy dx. For us to find dy dx, we need to say du dx times dy du is equal to 6, which is du dx, plus times our dy du, which is 7u to the power 6. When we say 6 times 7 times 7u to the power 6, we're going to get 42u to the power 6. And now, once we get our final result, we return the actual value, the actual inner function of u, which is 6x minus 1 minus 8 into place. Then we have our final answer of this derivative as 42 times 6x minus 8 to the power 6 is our derivative of this function. Let's now look at our second example of solving a differential equation using a chain rule notation. Here we have got the question that is saying, find the derivative of y is equal to the square root of 4x squared minus 3. So here we identify our inner function, which is 4x squared minus 3, and our outer function. So our inner function, we let u is equal to our inner function, which is 4x squared minus 3, and then our outer function is going to become y is equal to u to the power half, because u is 4x squared minus 3. So now we differentiate our inner function u in terms of x. So we're going to get du dx is equal to 8x. We differentiate to 4x squared. We say 4 times 2x to the power 2 minus 1, which reduces to 8x. And then we differentiate our outer function, which is y, in terms of u. So if we use our power rule, we're going to have half u to the power half minus 1, which reduces to half u to the power minus half. Minus half is our differential of dy du. So now, after getting our differentiation of outer function and inner function, we say now finding our dy dx with du dx times dy du. So du dx is 8x times dy du, which is half u to the power minus half. So when we multiply 8x times half u to the power minus half, we're going to get 8 over 2xu to the power minus half, and then I will retain the value, the actual value of u, which is 4x squared minus 3 in place of u. So we're going to have 4x squared minus 3 to the power minus half, which reduced to, when we take to reduce this minus, to remove this minus half, we take this expression to the denominator, then we are going to have 4x divided by square root. This to the power half means the square root of 4x squared minus 3 as our final answer. Let's now look at our third example of solving a differential problem using chain rule. So here we have the question that is find the derivative of y is equal to 8 divided by 3 minus 2x squared to the power 4. So the first thing that we have to do, we have to take our denominator up to the numerator. So we have got our denominator 3 minus 2x squared to the power 4, which is the power, which have the power 4 of positive. So when we take this expression up, it's going to change the status of the power to a negative 4. So we end up having 8 times 3 minus 2 x to the power 2 to the power minus 4. So now we have to identify our inner function. Our inner function is 3 minus 2x squared. So we let u is equal to our inner function 3 minus 2x squared, and our outer function is going to be y is equal to 8 times u to the power minus 4. So we differentiate our inner function, find as du in terms of x, which is du dx, and when you differentiate constant 3, you're going to get 0. So we differentiate minus 2x squared, and when we differentiate minus x2 squared, we use the constant multiplication in the power rule, and we're going to have minus 2 times 2x to the power 2 minus 1, which reduces to the value of minus 4x. And then we differentiate also our out function, which is dy in terms of u, which is dy du, and we use power rule, and we're going to have minus 4 times 8u to the power minus 4 minus 1. So we end up having minus 32u to the power minus 5 is our differential of the outer function. Now we need to multiply the derivative of the result of our inner function and our outer function to find the dy dx as du dx times dy du. So our du dx is minus 4x, then we say times dy du, which is minus 32u to the power minus 5, and we're going to get the result of minus 128xu to the power minus 5. So we change this minus u to the power minus 5, u to the power minus 5, for it to change the power to be positive. We need to take a u down to be a denominator. So we end up having minus 128x divided by u to the power 5. So 5 changes status, now the power 5 from negative to positive. And now we retain the actual value of u, which is 3. In place of u, we put it back 3 minus 2x squared to the power 5. And this becomes our final result of the derivative of our function. Here are some exercises to test your understanding and your knowledge. Find the derivative of each and every equation from question 1 up to question 8. Apply the correct differential methods and rules at each and every question. Refer to our previous examples that we have worked on in order to understand which method to apply at each and every question. Now we came to the end of our chapter 4 lecture for today. Thank you all for being part of Richfield Hybrid Learning Program. I wish to see you all in our next lecture.